which I think everybody was pretty comfortable with. And so what I want to talk about today is I want to talk about parabolas and the focus and the directrix. So this is a program in Desmos that basically goes over, oops, trying to make it a little smaller so I could see what I've got going here. So what this is this is a version of the formula that we were working with on Monday. So remember, this is the section that you want to have your notes, because we have this from out of your book, right? Where we're talking about what is a parabola and how can we define what a parabola is. And one of the ways that we can do that is we have a parabola. This point is the vertex, which the vertex is either the lowest point on your parabola, it's either the minimum or it's the maximum of your parabola. So that point, the vertex, you should have known about before and found. We have the axis of symmetry, which goes through a parabola. And then the two new things are that we have something called a focus, which lies on the axis of symmetry. And we have something called the directrix, which is perpendicular to the axis of symmetry. And as you can see here, from the parabola to the focus and from the parabola to the directrix, if you draw a line that is at 90 degrees, your segments are always going to be congruent to each other. Okay, so if I drew a line from the focus to my parabola and then parabola to the directrix, and this is at 90 degrees, then these two segments are congruent to each other. Excuse me. Same up here, right? From my focus to my parabola and then my parabola to my directrix, these two segments are congruent to each other. Okay, so this is Desmos. It's kind of taken that, and you'll see, actually what I'm going to do is I'm going to simplify this equation up here, because the equation that we're using on our sheet, excuse me, looks like this. Right, we're kind of using the simplified version of this. So you can see, if you pull up your notes, this formula right here, x squared equals 4py. That's the equation that we're working with in Desmos, okay? So we're going to actually ignore this h and this k. We don't need those two. So p represents some value. 4 times p equals that value that's in front of your y in your parabola. So all that to say is I just want to show you, oh, hopefully deleting that didn't break anything. Hold on, let me go back. There we go. We'll leave it like that. All right, so you don't really need to worry about these values. We're just going to set them at 0. They don't mean anything. So basically, this blue curve is your parabola. This yellowish, goldenish point is your, does anyone know what that's called? Okay, so this yellow part right here is called the vertex, right? And our vertex actually happens to be at 0, 0. Okay, this black dot represents the focus, our focus point, and the red line represents our directrix. So the reason I'm showing you this is that this is an easy way to move your focus point around and see what happens to your parabola. So as your focus gets closer and closer to your parabola, okay, as that gets closer and closer to your parabola, so the value of your focus, sorry, if I can slide it right here. As it gets closer and closer to 0, you can see that your parabola gets bigger and bigger, or not bigger and bigger. It gets more and more narrow, I should say. And as your value of p, which is the number before y, gets bigger and bigger, your parabola becomes wider. Okay? So why is that? That's because if you have a wider value, well, let's even pick pretty wide like that. P equals 3.5. Okay, if you have a wide value like that, by definition, Let me pull this up on here. By definition, if I drew a line from, see if I can get this all on here. If I drew a line from my directrix, which is this line down here. Oh, I thought that would draw a straight line for me. Maybe I have to use my line tool. There we go. If I drew a line from here to here, okay, and then I drew a line from here to here, then what's true about these two lines? They're congruent to each other, right? This line and this line should always be congruent to each other. That's the definition of a parabola. So then you can see if you make your focus point closer to your vertex, for example, if you make it closer, right? Then when you draw your lines, so if I draw a line from here to here, let's say, then that line should be congruent from here to here. Then these two lines should be congruent to each other. Okay? Does that make sense? So can you see how having the focus point closer to the vertex makes your parabola a steeper parabola? You guys following me? You're like, okay, I got it. Does that make sense? All right, cool. Thanks, Aaliyah. Okay, so we did a bunch of these in class. Remember, they're not actually too terribly difficult to do. What we want to do is graph the equation, identify the focus, the directrix, and the axis of symmetry of the parabola. Okay, so we're going to do this one here, which is number 4, because I think we did all the other ones in class, if I remember right. So it's x equals 1/3 y squared, right? X equals 1/3 y squared. So what we need to do in order to do this kind of problem is we need to look at what parabola does this look like? What am I going to use? So if I just look at the format, I have a y squared and a plane x. So I know it's going to be one of these two down here. Okay, and I don't have any negative values. So most likely my parabola is going to look like this one right here. Okay, it's going to look something like that. So now I just have to figure out exactly where is my focus, where is my directrix, and what does this look like? So I need to do a little work in order to get this equation to look like this. So right now I have x equals 1/3 y squared, right? If I multiply both sides by 3, then I get, I'm going to flip my equation around when I do it, y squared equals 3 times x. So then my equation looks like the sample equation that's given for this, right? I get a y squared equals 3x. I get a y squared equals 4px. So now what I have to do is I need to set whatever is before my x I know is equal to 4p. So 3 is before my x, and I know in my equation it's y squared equals 4px. x, right? So I need to set these two equal to each other. So in this case, I know that 4p is equal to 3, or p is equal to 3/4, right? Okay, so now I can use that to find out where all my points are. My vertex, right? My vertex is at 0, 0. My focus is at P0, and P is 3/4. So my focus is at 3/4, 0. And my directrix is at x equals negative P, x equals negative 3/4. Okay. So then if I go to graph all that, if I go to graph that, I know that my parabola is going to open to the right. Okay. And a really, really rough graph right here. So if this is x equals 1, x equals negative 1, 1, 1, right? I know my vertex is right here. I know my focus is right here. And my directrix is down here. Okay. So therefore, my parabola is going to open out this way. Right. And then if I go to Desmos to verify, this equation is off. So we're gonna do this. See if Desmos is okay with me switching it. There we go. Oh, and my p-value was, what was it? It was 3/4. So I can't exactly, it won't get that point over there for me because how it's graphing it. But so your parabola is going to look something like this. Well, it will look like this. I can't get the points to work. Desmos won't work for me. Okay, so how do you guys feel about that? Do you feel like you need another example of how to get that information? Feel good about it? Great. I'm getting some of my notes. Sometimes I get them on my phone, so. Okay. I want to do a little bit of 9.3 today, but I don't want to go too far in because I know you guys have chapter 8 that you're finishing up. So we're going to go a little bit of 3. So honestly, we'll probably wrap up a little bit early today. By the way, this section that we're in, this chapter that we're in, the parabola is one of a shape that we in math call conics. So you can see here there's a whole Desmos activity about it. So conics are parabolas, circles, ellipses, and hyperboles. I always say that wrong. Hyperbolas. Hyperboles is the English one. Hyperbolas. So we're talking about all these shapes that kind of have this curvature to them. So if you're like, why are we talking about all these random shapes? They're all shapes that have a curvature. So the beginning shape that we talk about is parabola because you're most familiar with that. We talk about circles. We're going to talk about something called ellipses. And then we're going to talk about hyperbolas. Okay. So if you want to on Desmos, there are like little activities that you can do on Desmos by, moving your focus up and down, flipping your parabola upside down, that type of thing, to practice with parabolas. There's also activities for circles, which circles are actually pretty cool, I think. Let me see what this pulls up. If not, we can just do it on our own. All right. Well, we'll just skip right into Desmos here and kind of do it. All right, so what is a circle? Do you guys all know what a circle is? You guys all know what a circle is, right? So by definition, if you have a circle with an origin of 0, every point around the circle is going to be equidistant from the origin. Okay, so this is our red circle, right? If I look at any point along my circle, it's going to be equidistant from the center, which is at 0, 0. So if I go from, if I go from the center to this point out here, it's going to be 3 units away. But also if I go from the center to this point out here, it's going to be 3 units away. If I go from the center to this point down here, it's going to be 3 units away. Center to here, it's going to be 3 units away. What do we call that in mathematics when we talk about the distance from the origin, the center point of a circle, to any point along the edge? What do we call that distance? I'll give you a hint. It's either radius or diameter. So what do you call the distance from the center to the outside of a circle? Is that your radius or your diameter? Radius, there you go. That's your radius, remember? So the distance from the center point to any point on your circle is your radius. And we use radius when we're trying to find the area and circumference of a circle. Remember, area equals pi r squared, circumference equals 2 pi r. So the radius of a circle is really important to know the distance from the center to any outside point. Okay. The cool thing is that if you want to draw any circle that has a center at 0, 0, okay, the general formula is x squared plus y squared equals the radius squared. Okay, so this is the general formula for any circle. And so if you make a radius of r of 3, right? Then you can see here that your radius is 3 of your circle. So the formula would actually be x squared plus y squared equals 3 squared. So it would equal 9. But the radius itself would be 3. So for any point from here to here would have a radius of 3. So then if you made your radius 4, then your circle goes out to 4. Okay. Have anybody seen the equation of a circle before? Cool. Okay. You don't remember. That's all right. We're talking about now. So this whole idea of this is the equation of a circle and this is what it looks like and here, this is an example of a radius of 4. Where does this equation come from? And this actually becomes really, really important in pre-calc, if anyone takes pre-calc. Okay. Anybody take pre-calc? Oh, let me do this. Let me make it a little easier for myself. I'm going to make it a radius of 5. Okay. And then I'll show you what this. So if you're going to take pre-calc, or even if you're not going to take pre-calc, still important to understand, where does this formula for a circle come from? So this is your circle. It has a radius of 5, right? If I asked you to tell me the distance from this point right here from the center to this point here, could you tell me what it is? This one's the easy question. So the distance between those 2 points is 5. It's not a trick question, right? It's 5 because that's the distance. If I went from the center here to up here, it's 5. But what if I went from here to, let me see if it'll let me flip it once I draw it. Can I flip it? Not going to let me do it. Then I want to flip it. I'm not good at my rotations here. Maybe. There, that's what I want to do. All right, so now if I gave you this picture, okay, and I wanted to know what is the distance from the center to this point out here? So this maroon line, how long is this line right here? So you guys told me, right? If I go from like here to here, that's 5. If I go from here to here, that's 5. What if I go from here to here? That is also 5, right? That's the definition of a radius. Any point from the center to a point on the circle is going to have the same radius. So even if I drew it out here, that's going to be 5, right? Well, the reason I drew it with a triangle, though, is to kind of show you that, let me take that off. There we go. So this is 5, right? Think about what this means. If you look at the scale, right, this is, and I look at my orange triangle, this is 4 units, and this is 3 units, and this is a right triangle. So what do we know about right triangles from math from a long time ago? Well, in right triangles, we know that a squared plus b squared equals c squared, right? It's the Pythagorean theorem. It's one of those ones you learned a while ago. So even if you just look at this right triangle, you don't know what the radius is. You know that your x component is 4 squared plus 3 squared, which just happens to work out to give you that c has to be 5 squared for this to work. And so the reason I'm showing you all this is that in upper level math, you're actually going to use something called a unit circle. And we're going to use our knowledge of triangles to find different points along our circle and to find angles. Okay. So I know that the whole definition of a circle isn't that complicated. It's always x squared plus y squared equals radius squared. But understanding that radius represents some point that can also be mapped up by a right triangle kind of helps you see where the formula comes from, right? So here we have our x, which in this case was 4, and our y, which was 3, and that equals 5 squared. So that's kind of where this formula from the circle, well, it is, the formula of the circle is derived from the Pythagorean theorem. Okay. right. Um, I think I'm gonna stop there because I wanna make sure that you guys are working on all your work. I'm happy to stay on if anybody has any questions, but, if not, I'm just gonna have you guys work on your homework to make sure that you get all of your chapter 8 stuff done, and then you get to start working in chapter 9, okay? Alright, guys. Thanks for coming, and have a good day, alright? Bye, guys.